Good evening, everybody, and a very warm welcome to the Yorkshire Local Centre of the Royal Meteorological Society. My name is Lindsay Bennett, and I'm one of the committee members for the centre. So I can see that so far we have 41 people who've logged in for this meeting tonight, which is great. I believe we have 90 registered, so I'm sure there'll be a flurry of people joining us very soon. As most of you will know, or some of you at least will know, the Yorkshire Centre is normally based at the School of Earth and Environment at the University of Leeds. And we normally hold monthly meetings in person, September to June. But obviously, due to current circumstances, we weren't able to hold our usual meetings. So we've been planning really hard to try and get these virtual meetings up and running. So we're really happy to be able to start this new series this evening. The meeting is being recorded, so you'll be able to watch this online on YouTube shortly after the event, and you'll be able to share the link with your family and friends too. Please bear with us while we get used to the technology. So Demio is a new venture for us all, and we're all getting used to it. But I would like to say actually thank you very much to the Society headquarters team for setting this up for us. There's been a lot of work behind the scenes to get this, bring this all together. So we're really appreciative of all the help that we've had, and we hope it goes well tonight. Just to let you know that for this talk, only myself and the speaker and the people behind the scenes have access to audio and video, but you as the audience have access to a chat function. So hopefully in the top right of your screen, you should see a chat button, and if you click on this, you're able to communicate to us with messages. So please let us know if you're having any technical issues. Hopefully you can all hear me and I'm not trying to lip read right now. But you can message us in this chat. So please feel free to do so. And throughout the talk tonight, please post your questions. So anytime you think of a question, please just put it in there into the chat. And what we'll do is we'll go through the questions one at a time at the end. Now, depending on how many questions we have, we might not be able to get through them all, but we'll do as many as we can. So the plan is for the talk to last about 30 minutes, and then we'll have 10 minutes for questions. Okay, so we've now got 45 attendees. That's fantastic. I'm going to give it just a couple more minutes, I think, and then I will introduce our speaker. So for anyone just joining us, a very warm welcome to the Yorkshire Local Centre of the Royal Meteorological Society. We'll be starting the talk very shortly. Just to reiterate that we have a chat function at the top right of the screen, and if you click on this button, you will be able to send us text messages. So do let us know if you're having any problems, and also please post any questions that you think of for the speaker during tonight's talk. You can post at any time, and then at the end of the talk, we'll go through these questions. Okay, so I'm going to introduce our speaker for this evening, Professor James Lee. Hi, James. Do you want to turn your webcam on?
Yeah.
Fantastic. Thank you. So thank you very much, James, for kickstarting our online transition. James is a Professor of Atmospheric Chemistry working for the National Centre for Atmospheric Science at the University of York. He did his undergraduate degree and PhD at the University of Leeds, researching free radical chemistry in the atmosphere. Following a short postdoc at Leeds, he moved to NCAS at the University of York as a research fellow, specialising in oxidation chemistry in the atmosphere and measurements of air pollutants. Recently, he has led the development of techniques to directly measure the emissions of air pollutants in order to validate national and international emission estimates. He's responsible for coordinating large-scale ground and aircraft-based field campaigns in the UK and around the world. and has led projects in Borneo, Beijing, Delhi, Uganda and London, just to name a few. Most of James's recent work has been on the effect of COVID-19 lockdown on air pollution in the UK, and that's what he's going to talk to us about tonight. So thank you again very much, James, for doing this, and looking forward to your talk.
Thanks, Lindsay, and thanks for asking me to do this. Yeah, I'm going to talk a bit about the effect of the COVID-19 lockdown on air quality in the UK. Before I start, I ought to acknowledge Will Drysdale, who's a current PhD student of mine, shortly to become a postdoc, who has done quite a lot of this work, particularly the sort of coding in order to visualize the data. So I'll get that acknowledgement in first, so I don't forget it. So I just thought I'd give a sort of very brief introduction into air quality and why we're concerned about it. So sorry for people that this is all sort of obvious stuff for, but I thought it's worth doing. We consume a lot of air. We eat about 1.3 kilograms of food a day. We drink 2 liters of water a day, but we breathe in over 10,000 liters, around 10 kilograms of air per day. It's obviously an important thing to know what it is we're breathing in and that it's clean. A little bit of history. Urban areas have got a long history of air pollution. Some of the first things that you can find if you Google it are from the 1600s, about London's inhabitants breathing nothing but an impure and thick mist. So these sort of observations of poor air quality, particularly in big cities, have been around for a while. I guess when they first really started to come to the fore was after the invention of the steam engine in the 1700s and the Industrial Revolution, which led to a massive increase in coal combustion, and particularly in the UK, the deaths connected with air pollution were more in the UK than worldwide. But obviously the industry's developed globally as well. And you can find sort of pictures of air pollution. This is a Lowry, obviously, from Manchester in 1926. But the one sort of most people know about, so there's one, and this is where the term smog comes from, which is the term smoke and fog sort of joined together. So that's where we get the term smog, and this came from some air pollution events in Scotland in the early 1900s. Like I say, the one most people have heard of is the Great London Smog of 1952. Just thought it's nice to show a few pictures of what things were like there, especially that one with people wearing some face masks. Don't look particularly well fitted, but anyway, picture of Leeds. So it was not just in London, actually, this event, it was all around the UK. And what people noticed was that you could correlate the amount of sulfur dioxide, the amount of smoke in the air with the amount of deaths. And in particular, that the excess deaths of people sort of lagged behind the air pollution. So that was one of the first times where excess deaths were really put down to this air pollution of this particular event. And that led eventually to the Clean Air Act of 1956, where after that the amount of sulfur dioxide in particular and smoke in the atmosphere dropped pretty rapidly throughout the late 20th century. Largely because of the movement of things like power stations and industry outside of cities. These are 4 of these famous power stations in London that are no longer power stations. So what we did was we moved the industry out, so that affected particularly things like sulfur dioxide. The levels in the cities dropped off. But that didn't, of course, solve the problem. So air pollution today, urban populations are growing and have grown. It's estimated to be about 40% of people will live in an urban area by the end of the 21st century, and is still a significant factor in global health, actually largely to do with sort of traffic emissions these days. And if you search around the newspapers, you can always find articles about air pollution killing millions each year, and it's one of the major health risks all around the world, actually, at the moment. And it's believed to cause around 20,000 excess deaths per year, depending on how you count them in the UK. So it's a pretty major problem for the UK as well. Just to go in what the main air pollutants today, again, apologies for those of you that know very well all about this. So the main air pollutants in the UK that we're interested in and that will form the basis of the rest of this talk. So PM2.5, particulate matter of diameter of less than 2.5 microns, about a third of 3% the diameter of a human hair. And because they're so small, they're able to bypass the nose and throat and penetrate deep into the lungs and even get into the circulatory system. And there's now a lot of evidence there's a close link between the exposure to fine particles and premature deaths from heart diseases. People will have seen that the growing evidence of research that the exposure to air pollution or long-term exposure to air pollution could have an effect on people's the effect of the COVID virus on people. But I'm not going to say very much about that today. So we've also got NO2, so nitrogen dioxide. I always think it's quite a nice thing to put the Know Your Nitrogen Oxide sort of slide up. It's amazing the number of people that still call it nitrous oxide, which is a very different thing. But nitrogen dioxide is part of a group of compounds called NOx, which is nitric oxide and nitrogen dioxide, and essentially they're formed when fossil fuels are burned at high temperatures, for example, in vehicle engines. Nitrogen dioxide causes a range of effects on the lungs, increased inflammation, reduced lung function, that sort of thing. So it's a pretty dangerous air pollutant, and it's something that we're very concerned about, particularly in the UK and in Western Europe. And then ozone is the other thing. So you know that ozone occurs both in the Earth's upper atmosphere, what we call good ozone, that protects us from UV radiation, and then at ground level where it's an air pollutant. The complication with it is it's not emitted directly, but it's created by chemical reactions. That's kind of why I'm interested in it as a chemist, between the oxides of nitrogen that I just talked about and volatile organic compounds that are also emitted. And this can cause a variety of health problems as well: chest pain, coughing, throat irritation, particularly in people with underlying health conditions. So they're kind of the three air pollutants that we're concerned about, and there's UK government policy on these matters, and some of the things, the key questions that we're still looking for is why isn't NO2 going down as fast as we expect? The plot at the bottom there shows the last 5 years deseasonalized NO2 concentrations measured at all of the measurement sites across the UK. I'll show a map of the sites in a minute, and you can see that while it has been dropping from 2015 down to the start of 2020, it hasn't dropped as much as we maybe expect it to have done based on what the vehicles, the vehicle emission regulations are. And people will know about the Dieselgate VW scandal. That's partly to do with it. There are various other reasons as well. We don't think that particulate is improving very much beyond the sites right next to the roadsides. It's another interesting question. And what's happening with ozone? I've just sort of left that very much open. But I guess this sort of COVID lockdown has given us the chance to look at a very sort of severe event where certain types of emissions have dropped, and then that can help us maybe to answer some of these, or go some way to answering these questions. Just a quick introduction. I won't spend very long on this because people will have seen it a lot over the last few months. First identified in Wuhan, China. Up until a few days ago, there was over 13 million cases in 190 countries, and sadly over 500,000 deaths. But so what the countries have done to try and stop the spread of the virus is put severe travel and workplace restrictions in, and this has led to a really large drop in transport use and industrial output. So like I said before, it gives us a unique chance to study the effect of a very large perturbation of emissions from a particular source on the actual levels of air pollutants. Sort of early in the year, we started to see these type of articles in newspapers where satellite data from over China showing, this is early January, and you can see this is the atmospheric NO2, so nitrogen dioxide measured from satellite, looking down on China in January. And then if you take the levels in sort of for a few days in early February, you can see that they have dropped significantly due to the sort of lockdown in China. You can see similar things to over Europe, March, April, and then compared to March, April 2019 compared to March, April 2020. You can see the levels of pollutants are very much reduced. Obviously, this is from satellite data. Satellite data is not always the best thing to look at because you need clear skies and you don't get quite the sort of spatial resolution that you might get with in situ data, which is what I'm going to be talking about. I just thought this is quite a nice one. This is actually from the Guardian newspaper. That if you go to their page, there's a kind of slider there. This is the main India Gate in the centre of Delhi. She went to Delhi a couple of years ago to do some work, and that's what it looked like on the left. This is what it looked like a couple of months ago. So you can really see in somewhere like Delhi, where the air pollution levels are very high, particular particulates, it's made a visible difference to the air. So what about the UK? So this is just a timeline of what's happened in the UK. On the top, we've got the daily cases of confirmed cases of COVID-19. On the bottom, the red bars show the transport usage compared to normal. So you can see transport use dropped to around about 75% of normal in early April. It gradually creeped up again, and most of the data I'm looking at are going to be up until the end of May, when the first easing of the lockdown restrictions happened. So you can see for almost all of that period, transport use, the total transport use, motor vehicle use, was about 75% lower than it would be normally. So what we've done is to look at data from the DEFRA Automatic Urban and Rural Network, which is a series of around about 150 active sites across the UK. You can see them here. They're graded of different types, either in the rural areas or in urban suburbia or in urban background or urban traffic. So urban traffic sites are sites that are right next to the road. Most of my work will be comparing urban traffic and urban background, which make up the majority of the sites. You can see there's quite a lot of them in London. Obviously, it's the biggest, by far the biggest city in the UK. It has a pretty dense network of these sites. And they measure oxides of nitrogen, SO2, ozone, carbon monoxide, and particulates. I'm just going to look at NOx, ozone, and particulates. VOCs, which is the other thing that goes in to make ozone, are measured at a couple of sites, in 2 or 3 sites, so I'll make a brief mention of those as well. It's been a great facility. These sites have largely remained consistently running due to some great efforts from quite a lot of people throughout the lockdown. They produce live data, and if you know what you're doing, that like my student Will does, you can access it using various software packages and just download the data and visualize it in whatever way you want. So the first thing we sort of started to do is to look at some individual sites, and this is Marylebone Road, which is a well-known site in central London, basically along the Marylebone Road opposite Madame Tussauds. The picture there is not actually a very good one, but it's basically a sort of cladded shipping container. If you're ever walking down outside Madame Tussauds, you'll see it. It's about a 30-foot long shipping container. And what these stripes are here are the levels of, on the top, nitrogen dioxide, and so kind of each stripe is a day in different years, from 2015 going down the plot into 2020. And you can see the bluer colours are lower levels, and the red line there is the 23rd of March this year. So what you can take from that top plot is you can see a very clear reduction in NO2 from the 23rd of May right through. This is up to a couple of days ago, where NO2 is significantly lower than at the start of the year. I guess the other thing to sort of notice is that NO2 has a bit of all of these air pollutants have kind of a seasonal cycle. If you look at previous years, where the higher concentrations typically happen in the winter and lower concentrations in the summer. And that's one of the things we need to be able to deconvolute out of this is the effect of the weather on it. So if you look at the bottom plot, that's PM 2.5, and the first thing to take away from that is that the drop is much less obvious, even at this roadside site. On this colour scale, at least, it's a lot less obvious that there's been much of a reduction in PM 2.5. And I'll say a bit more about that in a minute. But you can clearly see the sort of seasonal cycle that we need to kind of deconvolute out of the data. Oh, what's happened there? Something across the screen. There we go. Right, so if we move to another site, which is about 5 miles to the west of Marylebone Road, North Kensington, which is what's called an urban background site. And that's in a school, basically in a school playground in the suburban area of West London. And you can see, whilst you can pick out the drop, there's a lot less clear in NO2 on the top one, and definitely a lot less clear in particulates. So, and you have to remember about these, this is an area where actually most people live. So the NO2 change is much less clear from pre-lockdown to sort of this post-lockdown period, although it does appear to be lower than the previous the previous 5 years. So what we then, like I said, a lot of the effect of one of the big things that affects air pollution, what keeps happening there, right, is the meteorology. That's not me clicking that about, so I don't know what's happening there. So if we look at the pre-lockdown period, so from January to middle of March 2020, this is a windrows taken from data at the North Kensington site. You can see that actually in 2020 it's a particularly strange year. It seems a long time ago now, but if you remember, we had a load of flooding and 3 certainly named storms that came through in February, and that's caused very large these strong southwesterlies that will actually cause levels of pollution to possibly be lower than we might expect them to be normally. And if we look at then the lockdown period, we've kind of changed at almost a complete change, where we've had quite a lot of easterly flows. The weather's been pretty decent since the beginning of April, and these are conditions where you might expect there to be high levels of air pollution because the wind is slacker, it doesn't blow it away as much. So one of the things we have to try and take out, and there are sort of very clever sort of modelling techniques to take out this meteorology. That's not what we've done actually. What we've done is basically compared our data to the average of the previous 5 years. I'm bringing back the plot that I showed before, and now this has got the 2015 data, 2020 data in it, and you can see that it's a very clear drop, even taking out the sort of general downward trend that we might expect. 2020 has been a very low year for air pollution, particularly around the lockdown period. So that's what we've done, and this is now all the sites. I'm not going to dwell on this for very long because it's obviously a complicated plot. This is all the urban traffic sites kind of plotted as a grid, again coloured by their levels of NO2, and the red line in the middle shows the lockdown period. The 2 red lines in that middle part there is the lockdown period. And then on the bottom plot, that's coloured by the change in NO2 compared to the previous 5 years. So blue squares show that the levels of drop were lower on that day compared to the average of the previous 5 years. Red spots show that they're higher. So you can see within the lockdown period, almost every site on every day has lower levels of NO2 than the previous 5 years. These are the urban background sites, so sites more in areas where people live away from large road sources. You still see a similar thing, although it's a bit less clear. If we do it for particulate matter, and now there aren't many measurements of particulate matter actually at urban traffic sites, you can see again the picture is much less clear. You've got some areas where the levels were quite a bit higher during the lockdown period than the previous 5 years. Again, we put this down to the meteorology of these sort of very good weather and slack conditions that cause the air pollution to be higher, despite the fact that the traffic levels are a lot lower. And again, at the urban background sites, you can see a lot of these red periods, which would be the good weather periods. So if we aggregate the data together from all the sites, which makes it a bit clearer to see, the top row here is NO2, the bottom row is particulate, and I've looked at rural background, urban background, and urban traffic. You can see actually at the start of the year, as I said, because of the meteorology, actually it was already quite a low year for air pollution. But there is a drop, particularly at the urban traffic sites after the lockdown, which is that dashed line again, that's the 23rd of March, particularly in NO2. But in particles, you really can't see a difference on average across the sites. Some days are higher, some days are lower. So the sort of take-home message is that actually it hasn't had a huge effect, at least on average, of on the particulate matter. And again, this is meteorology just comparing the pre-lockdown period in 2020 compared to the average of the previous 5 years. This is again wind data taken from London. And you can see the yellow pies mean that the wind is a lot stronger. So 2020 was a very strong wind year, which has caused the levels of pollution, actually ignoring anything to do with COVID-19 lockdown, were already lower in this year. The other thing to bear in mind, particularly when it comes to particles, is where the air has originally come from. And you can see these are 5 or maybe 2 day back trajectories, I think, to show the air arriving in Manchester. Actually, this is a plot from the University of Manchester. And you can see that on some of these periods, it's at cluster 4 and cluster 5, where the air has come from over Europe. These are the periods where we've seen the higher levels of particulates. So as well as the local meteorology, the transport of air from Europe, despite the fact that Europe was undergoing its own lockdown, picking up particles from other sources makes the particles a much more complicated issue to look at than the very local issues surrounding NO2, which is a lot shorter lived than the particles. We can break it down into different cities. So I'm now just going to talk about NO2, so we'll forget about particles for the minute. You can see slight different behaviours between the different cities. London has seen a drop, but the biggest drops we've seen are in cities like Leeds and Glasgow. We can do this for all cities. I've just picked these 6 as an example of their urban traffic sites, and then do the same for the urban background. And you see a similar story, actually, that cities like Leeds and Glasgow, and in this case Cardiff, have actually seen a kind of bigger drop than London and Bristol. And we need to look more into that and get things like traffic flow data, all of which is going to provide us with a load of interesting data for kind of years to come. This event. If we just sort of pull that into actual percentage changes, and you can see actually Leeds, Glasgow showing that the highest changes at their urban traffic site. This is the percentage change from this year compared to the previous 5. So they've all seen a drop of between 30 to 50, 60%. But again, the bottom plot shows particulates, and it's a mixture. Some cities have seen a drop, some cities have seen an increase, and this is largely going to be driven by the meteorology. Although for the few urban traffic sites, actually, if you average it, they are lower in particles compared to previous years. So just a brief summary of this part of the talk. You can see NO2 decreased during the lockdown at almost all urban measurement sites, around 35 to 55%. That's kind of in line with a 75 to 80% reduction in road transport, and the estimate being that around about 60% of NO2 in the UK comes from road transport. The rest comes from other sources, things like power generation and like domestic sort of heating, which probably haven't changed that much during the lockdown, might have even increased it in places. But the story for PM is much less clear, much more driven by meteorology. And this is a sort of message that shows how hard any extra reductions of PM 2.5 will be in the UK, because even if you reduce the traffic source, you've still got a lot of other sources present. I'm just going to finish off by talking a bit about ozone. I think we've got 5 or 10 minutes left. So as I said before, it's not directly emitted, but it initially exists in a photostationary state with NO and NO2, essentially just sort of going around this cycle, and then so NO reacts with ozone, forms NO2, which can then be photolysed by sunlight to form ozone again. We kind of get this cycle. So close to an NO source, i.e. close to a road, ozone is reduced by its reaction with NO to form NO2. where that gets perturbed is when you've got VOCs present and a bit further away from the source, where the VOCs, and apologies, I'm not going to leave this slide on for long, get oxidized by the OH radical, and then they can cause NO to be oxidized to NO2, which again then is photolized to form ozone. So you get excess ozone formed. It kind of perturbs this photostationary state at the top when you've got VOCs present and given time, so given a few hours for the chemistry to happen. So ozone's a complicated problem, but what we've just done initially is just to look at the data and what's actually happened to it. So if we plot our three types of site again, and this time we've got NO2 along the top row and ozone along the bottom, you can see that in the urban background and in the urban traffic sites, we've seen this reduction in NO2, quite a lot less than previous years, but ozone is higher, kind of by about the same amount. And that goes along with the fact that it's just kind of repartitioning the ozone is getting repartitioned from the NOx because the NOx is reduced, so you don't get this initial titration. But what we then want to do is to look at, is that actually the case? So now what we've done is for those 6 cities is taken what we call OX, so total oxidant, which is the sum of NO2 plus ozone. And what we see here, and you can see if you look at Cardiff, so OX is the bottom plot of all of these, looking at cities like Cardiff, Bristol, to an extent Leeds and London, we do see that OX is increased. So that there does appear to be some extra oxidant, so some excess ozone that's formed, not just a repartitioning from NOx, which is interesting. And actually, if you plot the total OX, the change in total OX in this year compared to the previous years, and plot that against the latitude of the site, you can see that the sites in the south essentially see an increased OX. The sites in the north either see a zero change or even a reduction. So it's a really interesting story as to what's going on there. A little bit of evidence, so we looked at the VOCs. Have the VOCs changed? Well, not much. These are 2 of the only sites that there are. There's a site in London at Eltham and at Marylebone Road. The purple bars here show when the total amount of VOCs have increased compared to previous years, the yellow bars where they've decreased on that day. And there's a balance between the two. There's not much change of VOCs. One of the things that causes ozone to be formed, causes these VOCs to be oxidized, is UV radiation. I've managed to get this is UVA data from a site in London and in Leeds, and you can see actually during the lockdown period, UV radiation has been very high this year. It's not immediately clear why that is. There's some people think that it might be due to lockdown, skies being clearer, that sort of thing. But it has been a particularly large ozone hole over the Arctic this year, I think. So we have seen high levels of UV, which will cause these excess ozone to be formed. And what's gone along with that is temperature also being a bit higher compared to what you would expect for this time of year. What temperature does is form biogenic, so naturally emitted VOCs. More of them get emitted at higher temperatures, and you can just see the grey bars here show the levels of isoprene, or the total OH reactivity of isoprene for 2017 to 2019 and 2020. And you can see, particularly at the urban background site, that part of the VOCs that's due to isoprene actually has increased quite a lot at Eltham, from around about 15% in previous years to more like 30% this year. So that could be some of the cause. We need to do a lot more work on this and run some actual models, but the ozone is certainly proving to be an interesting story. Just finally, I'm just going to finish off by looking at some air quality exceedances. So these show the sort of levels that you're not supposed to exceed for NO2, an hour mean of 200 micrograms per meter cubed, 24-hour mean of PM of 25 micrograms, and an 8-hour mean of ozone of 100 micrograms. So we just looked at all the sites in London and see how many exceedances have we seen. So for NO2, and you can see 2020, this is just data from January to May 2020, there's been virtually no NO2 exceedances this year. Now, while it has been dropping in previous years, that this is a significant drop, and this is almost certainly due to the lockdown. So what we will see is that this year will have been a particularly clean year with almost no NO2 exceedances, at least in London. Particles, there has been a drop, and despite all I'm saying about that it hasn't affected the particulate matter as much. Actually, at sites close to the road, there does appear to have been a drop compared to previous years. The yellow bars here, we've seen a lot less particulate exceedances. So at sites very close to the sources, they have had an effect on PM 2.5. And then ozone has gone the other way, as you might expect. So in the urban background, we've seen more exceedances, and particularly in the roadside, we've seen quite a lot more than in previous years. So one of the things that we're interested in is this change in ozone offsetting any gains we've seen in NO2. I'm going to skip over the recovery thing a little bit, but basically this is the end of May. You can see the traffic has continued to rise as we get into July, and these are my plots again, and you can see now extended to a couple of days ago, and you can see that while NO2 is starting to recover, it hasn't gone up as much as we might have expected due to the amount of traffic that there is now. And we're wondering if this is due to sort of congestion being less. So it may be that it only takes a small reduction in traffic to have quite a big effect on the NO2 in air pollution. So there's another really interesting study that as the traffic levels recover throughout the year, we can keep a check on what's happening to the air pollution and maybe provide some evidence as to how much traffic congestion you would need to reduce in order to have quite a significant effect on the levels of air pollutants. I'm going to skip over that one. So just a few final thoughts. We've seen a large drop in emissions, especially of traffic-related pollution, and we might only need a small reduction in traffic to see a big improvement. It's one of the things that's coming out of this. I like to describe this as giving us a window into the future to see what cities might be like in 20 years' time with a largely electrified vehicle fleet. We have a cautionary tale with PM coming from other sources and even other vehicle sources with sort of road dust and brake dust and stuff. And as I've said, whether we just move the problem onto ozone instead. We also might want to consider indoor exposure. While these levels of NO2 have dropped quite a lot on the roadside, during the lockdown, no one was actually out at the roadside. People were spending most of their time inside. So considering what air pollution levels are like in an indoor environment is also going to be really crucial with going forward. So it's given us a huge amount of data to look at. This is just sort of some very early work. Anybody that's interested can plot their own air quality stripe. We've set up a website. You can pick a site and produce this air quality stripe for NO2, PM and ozone for any site around the country. So feel free to have a play about with that. Thank you very much for your attention.
Fantastic. Thank you very much, James. That was a really interesting talk. Bang on time as well. Thank you. So if anybody has any questions for James and you haven't felt brave enough to ask it yet, please do post it to us. You can do this, if you don't already know, by going into the chat section on the right-hand side of your screen and posting a text message to us there. I can see we've got 11 questions already. So I'm going to start from the top. Bear with me. Okay, question. I think these are in order. Check I've got this in order of time. Yeah, oldest first. Okay, first question from Karen. Why was there such a drop in NO2 emissions in the winter of 2016?
I don't know that specifically. I'm sure it will be, so that these are not emissions, these are actual concentrations. So I'm sure it will be meteorologically driven. I don't know what I can't think back to the winter of 2016 at the moment. So yeah, that will be what it is. So that will be just the concentrations have been affected by strong winds or particular meteorology. So that's, I guess, what it is. I hadn't noticed that, to be honest, but that's well pointed out. But these are all things that we need to look at. There's a huge amount of data here, and sort of picking on individual things like that is something that we want to do going forward.
Okay, thank you. So Ben asks, how much area does one station represent? A street, a neighbourhood or a city? How many air quality monitoring stations would you like there to be?
Good question. The urban background sites represent a neighbourhood, possibly even you might consider it in some places they would represent all neighbourhoods like that in a city. The urban traffic sites do really only represent that particular street because they're seeing essentially the emissions from the cars as they drive right by it. So in a city like Leeds, there are 4 sites, I think, 2 background and 2 traffic. You'd probably like to see a few more than that, but the UK is very well equipped compared to other countries. It has an amazing network, so I would not like to criticise it at all.
Thank you. A question from Ugo. Dear James, thank you for this comprehensive and insightful overview. I'm wondering whether you have any thoughts on possible changes in the chemical composition of PM 2.5.
It's a question that's not really in my area. I mean, I think that obviously the traffic source will have, or the traffic combustion source will have been reduced significantly. There were some measurements of composition being made. So the UK set up actually sort of late last year 3 super sites that make measurements of these things, 1 in London, 1 in Birmingham, 1 in Manchester. I haven't seen the results yet. My guess will be that it will be more things like agricultural, so nitrate type aerosol, as opposed to the sort of more carbony type compounds that might come out of vehicles. I'm not an aerosol expert, but I'm sure there will be a change, and that will tell us quite a lot about the sources. So I know that the people that are experts in aerosol are very excited about this data. I'm sorry I can't give you more of a insight into that.
Thank you. Let's see who we got. Okay. Question from Polly. It would seem that agriculture is a major contributor to particulate pollution. I understand that some of this is because hitherto fertiliser was sprayed and is now dribbled. Has this made any significant reduction in the level of PM 2.5?
I will have to be honest, I don't know. I don't know that I can answer that question. I'm sure it probably has, but again, this is a big area of research. That agricultural particulate pollution is probably going to be the most important going forward. Over the next 5 to 10 years. So it's a good point. Again, something I've not really thought about. So I'm afraid I don't really have much of an answer to that.
That's okay. Thank you. So George asks, have there been similar reductions in upper air pollutant levels due to the reduction in air travel?
Again, I don't really know. That there are so few measurements made, and we did want to take the UK research aircraft up. People weren't allowed to do that, obviously, due to sort of workplace and social distancing restrictions. I guess the biggest thing probably from the reduction in air travel would have been the reduction in CO2, so in greenhouse gases, rather than the reduction in air pollutant. That will be the most important thing from that reduction in air travel. But in terms of air pollutants, it probably the source is probably the biggest source up there, but no one's living up there, so it's something that we don't really look at, and because it's so hard to measure. But yeah.
Thank you. I probably should have found this one first. I wonder if you can clarify what is a VOC. If you could go into a bit more.
Sorry, a VOC is a volatile organic compound. So it's anything from like methane upwards, methane, ethane, butane, anything with sort of carbon and hydrogen in it that's a gas.
Great.
Yeah, sorry, I should have said.
No, that's fine. I've got lots from the committee. I'm trying to find questions from other people. Yeah, there's one from Ben here, actually, because I was thinking of the same question. Do you have good links with policymakers to feed these results back to the people making decisions? How does that work? Because I was thinking in the same way that we've all been using Zoom and this technology, and we've shown how easy it is, how we can all work from home. Does the same thing apply to you know, how easy it is with a small reduction in air pollution, small reduction in transport, we can have such a big impact on air pollution.
Yeah, and it's a really good point. So there was it came out on the 1st of July, there was an air quality expert group report. So they put out a call for evidence in mid-April, certainly looking at the initial part of the lockdown. And I think about 60 people contributed basically similar data to what I've shown here. And that's all been sort of distilled down into a report on, you know, the initial effects of the lockdown. I think that, yeah, one of the most interesting things is, and presumably they'll have a similar thing as we go through the recovery, to look at things like, because obviously the recovery is going to be a lot slower than the initial lockdown, to look at things like that. Does just a small reduction in traffic have a big effect on air pollutants? So yes, we do have good links with the policymakers. So the air quality expert group then feeds into government policy, or at least it provides advice to government who then direct the policy.
Thank you. One from Nan. Since the 23rd of March, many people have relocated to home away from town centres and presumably use more fuel at home. Would you care to comment on the effect of that on the data?
Yeah, so that's the source that's probably left in NO2 and particulates is the domestic consumption. So that data will become available, I'm sure, when we can get sort of domestic consumption data. We haven't got that yet, but it's another thing that we will be able to look at to try and kind of deconvolute the traffic source, take that away, and that's why we always use this window into the future. If you take away the NOx source from traffic, which probably will happen in 30 years' time, what's left? And that's one of the things we want to look at. But we haven't got much information yet, I don't think, as to whether domestic consumption went up or down. Probably helped that it wasn't in the winter, so maybe people didn't have to have heating on as much. If we see more lockdowns, maybe in the next winter, that could be a different story. So, thank you.
One from Grant. National parks would be good places to test traffic congestion changes. During lockdown, the Peak District visibility was very good, but air quality has felt much worse since the massive congestion of weekends in recent weeks. I suppose that's more of a comment than a question.
Yeah, no, absolutely. And I mean, the issue is there aren't as many measurement sites in the background. We haven't seen much of a change. You couldn't really see it on the scale I put, but in the few rural background sites there was an almost indiscernible change in NO2 during the lockdown. So yeah, the particulates, because they're longer lived, yeah, the story is more complicated. But yeah, it's a very good comment there.
Thank you. Hugo asked if it'd be possible to post the link to the Shiny website to plot your own stripes. So we can certainly send that out to the registration list.
Someone's just done that in the chat.
Oh, right. Okay, excellent. I can answer that one. Question from Danny. Do you think there are possible medical implications of the extra UV radiation during lockdown?
I don't know. I mean, UV radiation isn't good for you. And I actually I knew I had this in. I actually did a bit of Google search just earlier on this afternoon, and there are some reports that the UK basically saw its highest ever UV days. But again, whether that's due to the lockdown or whether it was due to just sort of natural cycles, and yeah, UV isn't good for us. So well, at least those levels of UV are not. So yes, I'm sure there probably are. It's going to be a small effect though, because it was a relatively smaller period of time.
Okay, I'll do one last question because we've had about 10 minutes, so we will ask this one. Ugo asks, I'd be curious to learn more about the contribution of biogenic VOCs to the total VOC levels measured at those stations. Is there any speciated information available?
Yeah, so then my plot, actually, I was running out of time, so I flicked over it, but that plot did speciate it. So those sites speciate into 20 odd VOCs. I think the only biogenic one they measure is isoprene, but you can use that as a tracer for other biogenic species. So we have got that information, at least for London. The issue is there aren't many other VOC measurements around the UK, at least not that have been running long term. So that, yes, that data is all available. Okay,
fantastic. Thank you very much for that session of questions there. We've pretty much covered everything, a few more from the committee, but we can always send those to you by email afterwards. So although we can't clap, thank you very much, James, for a really great talk.
No problem.
Thank you. If I could ask Sam to put up the couple of slides just before we finish. And James, if you want to switch off your webcam. So just to say, everybody, thank you very much for joining us tonight. I hope you've enjoyed the talk. We are going to be continuing these talks. So the next ones are already planned for August. We're going to have 2 next month. On Tuesday, the 11th of August, we'll have Dr. Claire Ryder from Reading University talking about the Godzilla dust cloud. You may have seen this trending on Twitter in recent weeks. A very big Saharan dust storm that blew across the Atlantic into the Caribbean. So she's going to talk to us about that on the 11th. And then we're going to have a talk on the 26th of August by Nick Silkstone from the Met Office. And he's going to talk about global teleconnections and how that influenced this exceptional winter we've had earlier this year. So I hope you'll be able to join us for those. Please do register online ahead of those talks. And then just to say, here are various links for you to be able to get in touch with us. So if you're not already on our mailing list and you'd like to be, the mailing list is here. Please do sign up and then you'll get not too many updates, only a couple a month. We do have a survey if you have time to answer that for us, to let us know what kind of talks you might like to hear about, topics you'd like us to try and do in the future. And you can also join us on Facebook and Twitter for regular updates. So yeah, I think that just about covers it. Thank you very much for attending tonight, and we look forward to seeing you again at a future talk.